We're almost done with this model, so let's talk about this last part over here, the renal corpuscle itself. We've already identified some of the components, like the afferent arteriole, the glomerulus, and the efferent arteriole. But in order to make it complete, remember, this structure is going to filter blood, so it takes fluid out. You have to collect it. You don't just want it to go anywhere and everywhere, because that fluid must be collected and then drained into your renal tubule. So surrounding the glomerulus will be a capsule. It's called Bowman's capsule or the glomerular capsule. Bowman's capsule has two layers. There's a parietal layer here and here. That parietal layer is made up of simple squamous epithelium. It's basically a little shell that surrounds the glomerulus. Like I said, there's two layers to it. So there's also a visceral layer, a layer that sits directly on top of your glomerulus. These whitish colored cells here, they are called podocytes, P-O-D-O-C-Y-T-E-S, podocytes. And the podocytes make up the visceral layer of Bowman's capsule. They're little cells that have little extensions that work like fingers. If you look very closely, you can see those little extensions, and they interlock. The extensions are called pedicles. And the pedicles interlock, and in between them will be very fine, very small slits. These are called filtration slits. And the fluid moving out must be able to squeeze through those small slits. It's designed so that you don't lose big things out of your blood, like your formed elements. Your red blood cells, white blood cells, and platelets, those will not move out. Proteins, plasma proteins, those will not move out of here. They should all stay trapped in part due to the effects of the visceral layer or the podocytes. Once that fluid is in what we call the capsular space, which is just the space in between the glomerulus and the two layers, right, let me put it that way, it will then drain into the first section of your renal tubule here, which is your proximal convoluted tubule, and then it will continue on. Now, in looking at this, understand that filtration is due to the pressure that the glomerulus sees. That pressure has to be regulated because if it's too high, the kidney doesn't work right. If it's too low, it doesn't work right. So there are two things on this model that collectively we call them the juxtaglomerular apparatus. Juxtaglomerular apparatus, or JGA for short. The first component of it is found here in the afferent arteriole. Take a look at the afferent versus the efferent arteriole. What do you notice about them? What's different about this one versus this one? Yeah, exactly. Simple. One's thicker than the other. Why is this one thicker? It's because of these cells that they show you in the cutout here. They are called juxtaglomerular cells. They are made of smooth muscle, and they will help alter the pressure here within the glomerulus. Now, I'm not going to tell you how that happens. We'll leave that for your lecture, okay? But I may even have a spill about it in my handout. You can check there. But I'm not going to go in depth about it. I just want to show you where they are. So these are juxtaglomerular cells in here. That's why the afferent is thicker than the efferent arteriole. This little area, this is a tube, a portion of the tubule. This is the distal convoluted tubule. The cells, however, here are very close to the afferent arteriole. See that? These cells are called the macula densa. The macula densa. They are also part of the juxtaglomerular apparatus. So the macula densa. They also help regulate the pressure within the glomerulus. Once again, not going to tell you exactly how. I'll leave that for your lecture. But you should know these cells are the macula densa. Okay? And that's it for this model.